Hello and welcome to this introduction to the S&C Digital Twin platform that has been developed at Cranfield University under Shift2Rail's In2Track 3 project. This has been developed using Microsoft Power Apps with data contained in Excel loaded onto the Power Apps platform. The first step in the app is a login screen and is an added safeguard to protect any data that will be placed in the app. Upon login, we come to the menu page. In this screen, we see a list of the other projects running as part of Task 2.1 in In2Track 3. Each of these models refers to a subtask which would have one or more models under development. Our purpose for the development of this app was to create an interface that could enable interactions with the S&C virtual models being developed. As detailed in the report, the data behind the models and their potential variations of input parameters and their desired outputs was created in an Excel spreadsheet. The philosophy behind this approach was to deal with the aspect that, where an interaction between two models are desired, models may exist in different locations and at times in different companies and in different countries, often running different software. The main aspect of any desired interaction between models is to get the outputs of one model to feed into the inputs of another so that the result of the second model has been developed based on the output of the first, where these combined outcomes could then be stored and further interactions could then be sought, and so on. To realize this type of setup, an interface is needed. Selecting one of the models listed takes us to the interaction customization screen for that particular model. Here, the inputs for the model can be selected and potentially customized, and the desired outputs and their desired format to be selected, so that compatibility can be maintained. On consulting standards and literature on Rail S&C, it became quite clear that an extensive range of potential configuration options regarding the asset's parameters exist, with specific rules governing how the parameter options can be combined, where different selections of one parameter would filter the accessible options of others. In this case, we display some default parameters for a given particular model and can make some adjustments. Ideally, based on the selection of the desired parameters, the app would interface through TCP/IP Internet Protocol to a client app directly connected to the virtual model in question. However, with institutional firewalls and a short development timescale, this interaction needed to be facilitated manually. Selecting Download, we can grab the input-output parameter selections as an Excel spreadsheet, where the specific inputs and outputs desired for this particular interaction are listed, and the team running the virtual model can have a clear job order to work with. In this way, all the potential conversations for interaction with the model can be held in advance, with a full variety of potential options contained with a clear interface, which will significantly reduce the volume of communications required on requesting subsequent model simulation runs, thus simplifying the interaction process. Once the model has been run and the data can be uploaded to a data store that the interface can access, which can then be used to show the outputs on the resulting data screen. With response data attached to the interaction request Excel sheet, they can then be added to the database so that the resulting outputs can become input options for other models. As Microsoft Power Apps is quite a recent platform and does not appear to permit app users to update the contents of the data tray operating behind the app, updating the Excel sheets in the data tray needed to be performed manually. If future developments can include client apps on the model side or models hosted on a shared digital platform, and if the app can be developed to rely on data stored on Azure, the database could be updated in real time, and then this model interaction step would be more automatic. Furthermore, if the expected modeling waiting time could be displayed on a waiting ticket screen, the user can be informed how long before the results can be expected, and the entire model interaction could be contained within a single user interface, thus smoothing the user's interface of making model interactions. Returning to the model selection screen, we can take a look at a different model. Where appropriate, a visual aid would be useful in the parameter selection screen to remind the user of what they're interacting with. Here we have multiple model options as part of the wider developments for the vertical movement stub switch, where the visual aid here is indicating which train direction is being modeled. as different options need to be available. When the user has made their selections, the model request can be sent, and once the data is available to the app's database, the data can then be accessible via the interface for selection as inputs to other models where appropriate. And this brings us to the end of the demonstration for the S&C digital twin.